Okay, so the first one, if you remember from last time, I said when you have negative exponents, you flip, and I gave you the rules. I said if you have 1 over x to the negative a, that just becomes x to the power of a because you flip it and the exponent becomes positive. So that's what this is all about. Now here, this becomes very simple once you do that. 1 over 3 to the negative 2 just becomes 3 squared. And you have the plus sign. And 1 over 2 to the power of negative 3, 2 to the negative 3 just becomes 2 to the power of 3. That will give me 3 squared is 9 plus 2 cubed, which is 8. 2 times 2 times 2 is 8. That gives you 17. So this one is very easy. Okay. How about this here? Here again, we get a flip. You know, I told you last time, if you have x to the negative a, you make that 1 over x to the power of a, and that's how you make the exponent positive instead of negative. Now this will be 1 over 2 cubed plus 1 over 4 squared, which gives me 1 over 8 plus 1 over 16. Now the common denominator between these two here is the 8 and the 16. 16 will be the lowest common denominator. Then you know you have to multiply this by 2 and this by 2 to make them the same denominator. 1 times 2 here will give you 2. And then you have the plus sign, and that's 1. So this here, 1 stays the same because it already has 16 underneath. But this you had to multiply the bottom by 2, and whatever you do to the bottom, you do to the top. And therefore, the answer here will be 3 over 16. This one is a little bit harder. So this will give you 1 over. Now, if you remember, 3 to the, okay, so 3 to the negative 2. Okay, let me just revise here. This is 1. 3 to the negative 2 becomes 1 over 3 squared. Plus 2 to the negative 3 becomes 1 over 2 cubed. Now, some of you might argue and say, here you flipped it right away and you made it this plus this. Yes, here the plus sign was right in the middle. And each one here was separate. But here you have everything together here with a plus sign underneath, and the 1 is over everything. You don't have 1 over this and then 1 over that. So here this becomes a little bit more challenging. Now, this becomes 1 over 9 plus 1 over 8, which equals, yeah. Now let's just do the bottom here, okay? The bottom, which is, I'm just gonna do that on the side right here. So I'm just gonna do it in this box right here. We're just gonna take the 1/9 plus 1/8 and do it on the side here in this box to make this a little bit easier. So 1/9 plus 1/8. The common denominator here is 9 times 8 is 72. Yeah. Then you have to multiply this by 8 to make it the 72. Whatever you do to the top, you do to the bottom. And you have to multiply this by 9 to make it 72. Whatever you do to the top, the bottom you do to the top. Okay. Now in the top, 1 times 8 will give you 8. And 1 times 9 will give you 9. 9 plus 18, 9 plus 8 is 17 over 72. And therefore, this will be 1 all over 17 over 72. Yeah, because we still have the 1 on top. Now, fractions mean division. So this here, this fraction, which is this one here, is the same as 1 divided by 17 over 72. When that's the case, we change that we go 1 and we change the division to multiplication, and we flip the divisor. So we flip this, and that would be 72 over 17. Yeah, which 1 times anything, it'll be just that same thing. So that final answer is 72 over 17. Okay, so this one is a hard one. I expected most of you to get this wrong. This one, right, number 3 here. This I expected everybody to do it right, because that's what we've done last week. We've done a lot of practice on this. So what I said to all of you, make sure the first thing you get rid of the negative exponents. And to get rid of the negative exponents, just change the position of the number with the negative exponent. If it's on top, you bring it to the bottom, and that automatically changes the exponent to positive. Also, if it's on the bottom, you bring it to the top, and that also automatically changes the exponent to positive. So therefore, I'm going to put the 2 to the 3 here. And the 4 to the negative 2 is going to jump there and becomes 4 squared. Now, the x squared right here stays where it is because it's already positive. Y to the negative 1 is going to come down right here, and it becomes y to the power of 1. This also x to the negative 1 here is going to go to the top, and it's going to become x to the 1. And this y to the negative 2 will go to the top, and it becomes y squared. Now, what I have here, I have 16. X squared times x to the 1 is x cubed. Okay. Now, we have y here, and we have y squared. We reduce them. Y goes into itself once, y squared becomes y. So we have a y here, and then 2 cubed is 8. And that's what we get for number 4. Any questions so far? Any questions? Make sure you ask if you have any questions. Yeah. Is my voice cutting off, or just for one person? Is my voice okay? My voice is okay, yes? Okay, Athena, it's your internet is a bit weak, most likely. So try to find a place at home where the internet is a little bit stronger, and that's why you get in the voice to cut off a little bit. Okay. All right. So now I'm gonna go to this one. Any questions so far? Any questions? You know, you could send your question privately. Like you don't have to speak up. If you have a question, make sure you ask, because we'll be done after this with exponents. We're gonna go to polynomials. So I guess no questions. Okay. How about when you have this here and you have an exponent outside of the brackets? What you should do in this situation here, it's much easier to simplify what's inside first, okay? So how do we simplify? We reduce. 3 goes into itself once, 3 goes into 9 3 times. X squared goes into itself once, it goes into x cubed x times. Y squared divided by y squared gives you 1, y to the 5 divided by y squared, y cubed. So when I say it goes into itself once or divide by itself once, so dividing is the same as goes into itself. Okay. Now, if you look at what we have now, this question became a lot easier. It became y cubed on top over 3x on the bottom, because 3 times x times 1, just 3x. And then you have the square still there. Now you apply the square, okay? When you apply the square, remember that 3 has a 1 on top and the x has a 1. And you multiply the exponent outside into all the exponents inside. And that will give you y to the 6, 3 squared was 2 times 1, and x squared. And your final answer should be written as y to the 6 over 9x squared. Now, please, if you have a question, let me know now, because we're going to go to a new chapter. Does everybody understand everything here? And if you do, please say yes. So only one person answer I know all of this. Okay, so some students want to do more practice of this. Okay. I need to hear from everybody, by the way. Okay. So another student wants more practice before we go into polynomials. Got more practice. You know, like with this speed right here, you know, we're not going to be able to finish half of the course. So most likely we'll be adding about 2 more months to the course if that's the speed we're having. So, but anyways, we want to make sure everybody understand things. How come Y is at the top? And which question? Is that question number 5? Ahmed, is it question number 5 that you're asking? Okay. So if we have y to the 5 over y squared, we reduce, okay? We reduce. So if we're reducing, I divide both of these by y squared. So y squared divided by y squared gives me 1. Y to the 5 divided by y squared gives me y cubed. That's what we do. That's reducing fractions. Does that make sense now? Okay, great. Yeah, so everybody wants more practice. So I'm gonna give you more practice. So now I'm gonna start doing these, and then you look at your answer and see how you did. So for the first one, it's very simple. As we said earlier, you flip this, you make the exponent positive. So this will be 5 squared minus 2 to the power of 4, which equals 25. And 2 to the power of 4 is 2 times 2 is 4 times 2 is 8 times 2 is 16. So you multiply in 4 2s together, that gives you 16. 25 minus 16 is 9. This here, you flip, you make the exponent positive. So this will be 1 over 5 squared plus 1 over 2 cubed, which equals 1 over 25 plus 1 over 8. The common denominator between 25 and 8, don't multiply the 25 and 8 to find the common denominator here. Try to look at the possible multiples of this. So look at the multiples of this and see if the 8 goes into it. But I'm just looking at it now, and I know if you do 25, 8 doesn't go into that. 50, 8 doesn't go into that. 75, 8 doesn't go into that. 100 doesn't go into that. And this common denominator here is going to be basically multiplying these two here, which is 200. Now listen to this. You know, there's a different way of doing common denominator. I go 200 divided by 25. That gives me 8. That means I have to multiply this number by 8. So I have 8 right here. And I have the plus sign. And then I go 200 divided by 8. That gives me 25. That means I have to multiply this by 25. And therefore, the answer will be 8 plus 25, which is 33 over 200. This one is a bit harder. This one, you're going to have 2 all over. This, I'm going to flip this, make it 1 over 2 cubed. minus, this is going to be 1 over 2 squared, which gives me 2 over 1 over 8 minus 1/4. Now again, I'm just going to take this 1/8 minus 1/4. I'm going to do it on the side. So I'm just going to do it here. Yeah. 1/8 minus 1/4. The lowest common denominator here is going to be 8. Don't multiply the 8 and the 4, because since 4 goes into 8 twice, then you don't need to multiply 8 and 4. Here, we had to multiply because there's no, the lowest common denominator will be 200. But here, the lowest common denominator is not 32, it's 8. Now, again, I divide 8 by 8, I get 1. So that means I multiply this by 1. So 1 times 1 is 1 minus, and then 8 divided by 4 is 2. That means I have to multiply the top number by 2, which gives me 2. And that will give me negative 1 over 8. So now I have the 2, which is still on top. And on the bottom, I have negative 1 over 8, which equals 2 times. Remember I said this means division right here. So you change the division to multiplication and you flip this. And when you flip this, it just becomes negative 8 over 1. And remember I said if there's 1 underneath, you don't have to write it. In a fraction form, if you have negative 8 over 1, you shouldn't write that like that. Just write it as negative 8. As I said, fractions mean division. So negative 8 divided by 1 will just give you negative 8. Okay. And therefore, your final answer will be negative 16. Now, we're going to go to the next question right here. Here, your best bet is to make all the exponents positive. And again, if some of you have forgotten, all you need to do, if you have something that has negative exponent, if it's on the numerator, bring it to the denominator, and that makes the exponent positive. And vice versa. If it is on the denominator and it has a negative exponent, just bring it to the numerator, and then the exponent becomes positive. Just give me 1 second, Noor. Okay, let's go to Noor's question. Exponents have to be positive. This is not an exponent. Exponent is on top of a number. That's what an exponent is. So if I have negative 16, I'm not going to say that is 1 over 16. No, that's wrong. That's a common mistake that we see, because that's not an exponent. That's just a number. That's an integer. Only exponents, when they're negative, we flip and make the exponent positive. Okay, good. Good question, though, because it's a common mistake that students make, and it's good that you clarified it. Okay, so here, the only thing that doesn't have a negative exponent is the y squared. So that's the only thing that's going to stay on the bottom, or stay where it's supposed to stay, where it is. You know, it's on the bottom. It has a positive exponent, therefore it stays on the bottom with the positive exponent. Everything else here has to change position. Like if it's the x to the negative 5 is on top, it has a negative exponent, bring it to the bottom and make the exponent positive. Y to the negative 4 is on top, it has a negative exponent, bring it to the top, make the exponent positive. 8 to the negative 2 is on the bottom, negative exponent, bring it to the top, make the exponent positive. X to the negative 10 is on the bottom, bring it to the top, make the exponent positive. And that will give me the 8 squared is 64. X to the 5 on the bottom divides by itself and gives me 1. X to the 10 divided by x to the 5 and gives me x to the 5. So I have x to the 5 on top. And on the bottom, I have y to the 4 times y squared right here will give me y to the 6. Okay. How about here. Here, trust me, always simplify the inside first, so your life will become a lot easier. So what do? You keep the brackets, keep the negative exponent right here. 2 goes into itself once, goes into 6 3 times. That's just reducing fractions. Like, don't think that's an exponent and all of that stuff. All right, here, x to the 7 divided by itself and gives me 1. X to the 9, when you divide by x to the 7, gives me x squared. Y to 6 divided by itself gives me 1. Y to the 10 divided by y to the 6 gives me y to the 4. So therefore now I have x squared left on top. I have 3 left on the bottom, and I have y to the 4 left on the bottom. Now, since this is a negative exponent, you remember the rule I gave you before. I said if you have x over y to the negative a, to the negative exponents, all you need to do, flip all of this, make it y over x, and that makes the exponent positive. So we're going to do the same thing here, even though it's more than just x and y here. It's a lot of stuff. But what is this is saying? Saying just flip it, whatever's in here, flip it, make the exponent positive. And therefore, I'm going to flip all of this. So I'm going to have 3y to the 4 over x squared. Now the exponent becomes positive 3. Remember, we put the exponents in, all the exponents in here, exponent outside of the brackets, you multiply it into the exponent inside the brackets. So that will give me 3 cubed y to the 12 x to the 6, which gives me 3 cubed is 27. You have to simplify that. Y to the 12 x to the 6. And that's your final answer. Okay. Hopefully I recorded. Just give me a second. Yeah, I am recording. Okay, so does that make sense, everybody? Please say yes. And all of this will be sent to you guys. But make sure you watch the videos. Like I sent some of the videos to some, and some students don't bother watching them. You know, it takes me quite a bit of time for me to edit all of this stuff and then put in the effort, put it on my YouTube channel for you to watch, because that's a lesson that you should be watching. Negative exponents next year are going to be a major part of your course. It's going to be a whole chapter, and you know, you want to understand this. And again, if I may repeat, okay, remember this course is designed so that you have a preview of the course. So at least when you go to the course, you kind of understand. Even if you understand 50%, it's good, because then when you go to the course, then you take care of the other 50%. You know, we're not expecting everybody to be perfect on this, but at the same time, we don't want you to be completely lost either. And that's why you ask a question if you're if you find this some of these questions a little bit hard. So now it's a chance for you. If you want me to go over any of these 5 questions, let me know, because the next thing I'm gonna do is a different chapter, which is maybe a little bit easier, you know, than negative exponents. So any questions? Just wait for 30 seconds. Okay. Question 5, I'll do that again. I'll do one like it, okay? Give me a second. Let's take a break right now, Rama, and then when we come back, I'll give another example like that. And after that, I'm going to go into the other chapter. Okay. Yeah, let's take 10 minutes break, please. Now, here's a question that for some of the students asked me to give them one more example of these. So here, always reduce what's inside first. Don't worry about this yet. Don't worry about the -2. Reduce the inside. When we're reducing, first of all, 3 over 12, you know, that's just the same as 3 over 12. 3 goes into itself once, it goes into 12 4 times. So that's what you're doing here. X cubed over x to the 8, all you're doing is, this is the lower exponent, which is the 3. Then you divide both by x to the 3. That gives you 1. And when you divide this by x to the 3, remember minus the exponents, you get x to the 5. So x to the 3 goes into itself once, it goes into x to the 8, it x 5 times. And y cubed goes into itself once, it goes into y to the 7, y to the 4 times. Now what we have y to the power of 4 on top, and on the bottom I have 4x to the 5, all to the power of -2. What you want to do now, you want to flip this, make the exponent positive. So what you do when you're flipping this, you're making the exponent positive. So that will give me 4x to the 5 over y to the 4, and that will make the exponent +2 instead of -2. Remember, the 4 has a 1 on top, so this will become 4 squared x to the 10, because you multiply the exponent outside the brackets into the exponents inside the brackets. And that would be y to the power of 8, which gives me 16 x to the power of 10 over y to the power of 8. Okay, so for the student who asked the question, does that make sense? So for everybody, does it make sense? Okay, good, good. All right, so we're moving on to the next section, which is polynomials. So adding and subtracting polynomials. I'm going to do one example for you, and then I want you to do the other 3. Okay, so I'm going to do example 2. So when we're adding and subtracting polynomials, I look for like terms. Like terms, see how this variable has x squared and this has x squared. These two here, we call them like terms. So I underline them like this. And the other ones, all of them, they have xy, xy, xy. So these also are like terms. So I kind of underline them with a wiggly line indicating these terms are alike, and then these two terms are alike. Now, some of you, you like to bring everything together that are like terms. You don't need to do that, okay? Because that's a waste of time. What do you want to do? You want to do this operation here, this and this, because they're like terms. So you go 4x squared, and you don't read the sign here. You go 4x squared, and this minus 3x squared, that will give you 1x squared. So the answer is 1x squared. Okay, so that is done. We finish with this. Here, remember, if we don't write anything here, that's a -1. So this would be a -1 plus 3, which is 2. 2 plus 7 is 9. So that will give you 9xy. Does everyone understand what I did? I could explain it again if needed. So please answer yes if you understand it. And I need to see 8 yeses, otherwise it means some of you didn't understand. So we have only 1 yes, 2. Okay. 4, okay. Yeah. Okay. So I'm just going to explain this again. Now, when we are adding polynomials, we look for like terms. Like terms means the variables will be the same and they have the same exponents. So in here, the 4x squared and the 3x squared, they are like terms. Anything that has xy like that, also like terms. So I'm just going to put a wiggly line indicating these are the same. These 3 of them are the same. Now you go 4x squared minus, this is the minus, 3x squared will give you 1x squared. And here there's a -1 in here. You just go -1xy plus 3xy will give you 2xy. And then you jump plus 7xy, 2xy plus 7xy will give you plus 9xy. Does that make sense now? For the student who answered, asked, sorry, for the student who asked, okay, good. Now do number 1, 3, and 4. And I'll give you 8 minutes to do them. So I'm gonna start answering these, and you guys check if you got the right answer, okay? So I'm gonna underline like terms. So this has an x squared, this has an x squared, these are like terms. This has an x and this has an x, so they're like terms. And the constant here, and that's a constant, so they're like terms. -12 plus 7, that's -5x squared. Then I have -4x jump plus, -4x jump, and it's minus 10x. That will give me -14x. So if your integers are an issue, you could use a calculator, because honestly, by grade 10 and grade 11, if you haven't gotten integers yet, and integers are very easy. Somehow some students cannot wrap their heads around it. This is -4x minus 10x. I cannot slow down and give you, like, explain integers to you anymore, because that's, you're supposed to be coming to math 11 or math 10, sorry, understanding integers. So -4x minus 10x is -14x. And then we have 11 minus 6, that's plus 5. And then here, the like terms are these, and then this, and then these right here. So that will give me 14g squared jump minus 8g squared. That will give you 6g squared. Okay. Now -5g minus 6g, -5 minus 6 is -11g. 10 minus 19 is -9. And that's the answer for this. So again, it's 10, positive 10. You don't read the sign here. You go positive 10, and here, minus 19. That's -9. Okay. Here, this is a like term with this. This is a like term with this. And this is a loner, doesn't have any like term with it. So you cannot do anything about this. Now, 6a squared b minus 11a squared b, 6 minus 11 is -5a squared b. And then -2a squared b squared plus 5a squared b squared. So the wiggly line, I just know that they are like terms. So I jump from -2 plus 5. That's plus 3a squared b squared. And then I have this, which is a loner, nothing like, so I'm just gonna still write it as part of the answer. Any questions? So I'm gonna give you one example from here, and then I expect you to do 1 and 3. I'm gonna do number 2, okay? So pay attention here. When you multiply in monomials like this, all you need to do is multiply the -3 times 2, that gives you -6. Multiply the a squared into the a, and the a here has a 1 on top of it. So when you multiply, you add the exponents, that's going to give you a cubed. And then b times b squared, again, the b has a 1 here, so that's also going to give you b cubed, because 1 plus 2 is 3. So that's what you get for an answer for number 2. Here you have 3 things, you just carry right through. You go 3 times -2 is -6 times -4. So don't do it in like, don't do this first and then just do everything all together. All right. So try 1 and 3, and we'll pause here the recording, and we'll come back. The first one, you only multiply the 8 and the -5. or part of it, you multiply the 8 and the -5, you get -40. X, you don't have an X here, so that's just going to stay as an X. But Y times Y is Y squared. Remember, I said if there's nothing written on top of the variable, that means there's a 1, invisible 1 that we don't write. Okay. Here, we have 3xy times -2x squared y times -4xy squared. As I said, multiply right through, you know, so you go 3 times -2 is -6. -6 times -4 is +24. Now, of course, all the variables here that don't have an exponent, that means they have 1. So therefore, here the x is x to the 1 times x squared, that's x cubed. You remember you're adding exponents. X cubed times x to the 1. You add the exponents again and you get x to the 4. Y to the 1 times y to the 1 will give you y squared. Then y squared times y squared will give you y to the 4. And that's the answer for this one. We're going to finish off with a few that are a little bit harder. Now I have this multiplied by this, all of it divided by this. The first thing we have to do, take care of this exponent right here. You remember the 2 has a 1 and the x has a 1. So 3 times 1 is 3, so that becomes 2 cubed, and 2 cubed is 8. And we have x cubed, and 3 times 2 is 6 here, so y to the 6 times 3x to the 5, y to the 4, all over 4 x squared y to the 5. Now after that, I multiply these. So 8 times 3 is 24. X cubed times x to the 5 is x to the 8. Y to the 6 times y to the 4 is y to the 10. All over 4 x squared y to the 5. Now we're dividing, or we reduce. I like to call it reducing. So 4 goes into itself once. It goes into 24 6 times. X squared goes into itself once. It goes into x to the 8, x to the 6 times. Y to the 5 goes into itself once. It goes into y to the 10, y to the 5 times. So basically, I'm dividing this by y to the 5. Get 1, divide this by y to the 5. I get y to the 5. So we only have 1s on the bottom. So 1 times 1 times 1 on the bottom, just 1 on the bottom, which we don't write. And this here will just end up giving you 6, x to the 6, y to the 5 for a final answer. So send me this for homework. Okay, this is your homework. Please send it to my email. That's aplctutor@gmail.com. Expect all 9 of you to send me the answers for this one. Thank you for attending today. I'll talk to you later. Bye-bye.